Good morning. I'm going to talk a little bit about the area of composite circles, which is going to be a combination of circles or other figures where we're going to look at one size of a sector and subtract a triangle from it or something along those lines. So first off, what's a sector? Well, a sector is going to be this particular part or portion of a circle. So that's a sector. And when we're going to be finding the area that it's going to be a percentage of the area of the entire circle. The second thing we're going to talk about is going to be a segment. A segment is going to be a piece of a circle as well. It's a part of a sector. So if you think of it as finding the area of this sector that we just talked about, and then subtracting the area of the triangle, what we're going to have left is the area of this segment. And then the third thing is going to be an annulus. An annulus looks like there is concentric circles, and we're looking at this part right here. So basically, we're going to take this large circle, and we're going to subtract from that the area of the small circle, and that's going to give us the area of the annulus. All right, so more specifically, how do you get the portion of whatever it's going to be? Well, remember when we did arc measure and arc length, we said that to determine this arc length, which was part of a circumference, we had to determine the arc measure. Remember, the arc measures of this is going to be exactly the same as your central angle. So when we're looking at this one, just to make it simple, say that this is 90 degrees. We know that there's 360 degrees in the entire circle, and this sector has 90 of that. So that's going to be the ratio set for this particular area. So simplifying that ratio, 90 over 360, that's going to be 1/4. So the area of that particular sector is 1/4 the area of the entire circle. Remember, that's going to be pi r squared. So then we just have to know what the radius is, and we can put that in there, and that's going to give me the area of that particular sector. So then let's look at a segment. For a segment, we have this chord drawn in here. We still have an arc measure to use, but we don't have is the sector part. So we need to draw in these two radii. And again, this measure right here is the same as this measure. So we're just going to call that n. So it's going to be n over 360 degrees. So that's going to be your ratio. Then you're going to have pi r squared. That's going to give me the area of the entire sector, like we just did in the previous slide. Now, what we're going to have to do is we're going to have to subtract the area of the triangle from that. And we've done area of triangle, so we're going to subtract the area of the triangle, which is 1/2 the base times the height. And once I do that, that's going to give me the area of the segment. The last one is the annulus. It's probably the easiest of them. We're going to take the area of the large circle and we're going to subtract it from the area of the small circle. All right, so we need the radius for the large one. So that means the area is going to be pi r squared minus, we need the radius for the smaller one, so we'll call that radius 2. We'll call that one radius 1. We're going to have pi r2 squared. And that's going to give me the area of the annulus. So now you should be able to go to the worksheet and use this and look at them a little bit different in that they're going to be parts of circles subtracted from other types of areas, either that being a circle or a triangle or something. Good luck.